This is a continuation of the joint probability distribution. We're now going to have another topic, the conditional probability mass function. Let x and y be two random variables, may it be discrete or continuous. The continuous distribution of the random variable y, given that x is equal to x, is denoted by f of y sub y given x is equal to f of xy sub xy all over f of x sub x, provided that f of x sub x is greater than 0. Similarly, the condition of the random variable x given that y is equal to y is given by f sub x given y of x is equal to f of xy sub xy all over f of y sub y, provided that f of y sub y is greater than 0. The conditional probability mass function example. For the conditional probabilities of a mobile response time in the previous example, example 5-1, x and y denote the number of bars, a signal strength, and times you need to state your departure city received. Then, if we are going to take the sums, so vertically the sums would be 0.15 plus 0.02 plus 0.02 plus 0.01, so it would be 0.2. Let us first evaluate the marginal distribution. And then we have 0.1 plus 0.1 plus 0.03 plus 0.02. It would be 0.25. And then we have 0.05 plus 0.05 plus 0.2 plus 0.25. So that is 0.55. So these are the f sub x's. For f sub y, so 0.15 plus 0.05 is 0.2. So this would be 0.3. And then this would be 0.17, 0.25, and then 0.3. Let's verify. I think some of the values went wrong. So 0.15 plus 0.1 plus 0.05. 0.3, 0.02 plus 0.1 plus 0.05 is 0.17, 0.02 plus 0.03 plus 0.2 is 0.25, and 0.01 plus 0.02 plus 0.25 is 0.28. Sorry, correction for this one, 0.28. So for the probability of y given 1, given that x is equal to 3, would be x is 3, y is 1. So x is 3, y is 1. So that is 0.25 over 0.55. So that's 0.454. For y is equal to 2, given that x is equal to 3, so that would be 0.2 over 0.55, so that's 0.364. So we can have the values of y. The values of y are 1, 2, 3, and 4. So for the probability of y given x is equal to 3, so we have 0.454, 0.364. For x is equal to 3, this one, 0.05 over 0.55. And then for this one, it would be 0.05 over 0.55. So it would be 0.0909. So observe that if you're going to add all of these values, we're going to have a total probability of 1 for the probability of y given x is equal to 3. So let us consider this probability distribution. So we are given the marginal distribution as well. We have the column totals and the row totals. So find the conditional probability of x given y is equal to 1. So we're looking for the probability of x given y is equal to 1. So we are considering this totals. So we have x would be 0, 1, or 2. So for x is equal to 0, it would be 3 over 14 over 3 over 7. While for 1, it would be 3 over 14 over 3 over 7. While for this one, it would be 0 over 3 over 7. So for x is equal to 0 and 1 because 2 would be 0. So the probability of x given y is equal to 1 is 1/2 and 1/2. Let's have another one. Let x denote the number of times a certain numerical control machine will malfunction 1, 2, 3 times on any given day. Let y denote the number of times a technician is called for an emergency call. Their joint probability distribution is given by this one. So let's evaluate the marginal distribution of y, and find the probability of y is equal to 3 given x is equal to 2. So if we're going to add this, it would be 0.1, 0.35, 0.55. Observe that if you're going to add that, it should be 1. Let's have another check for horizontal. So it would be 0.2, 0.5, and 0.3. So we can have x and f sub x. The values of x would be 1, 2, or 3. When x is 1, it would be 0.1. When x is 2, 0.35. When x is 3, 0.55. For marginal distribution of y can be 1, 3, or 5. So f sub y is 0.2, 0.5, and 0.3. So this is A, B, and C. So for the probability of y is equal to 3, given that x is equal to 2, so this is f sub xy of x is 2, y is 3, all over f sub x of 2. When x is 2, y is 3, so that is 0.1 over f sub x of 2, 0.35. So this would be equal to 2 over 7. If we will be having a probability density function, so the same applies. Instead of summation, instead of adding vertical and horizontal values, we're just going to do integration. So let's have an example. The joint density function for the random variable x, y, where x is the unit temperature change and y is in the proportion spectrum, shift that certain atomic particle produces, is the joint density function f sub xy of xy equal to 10xy squared, where x is from 0 to y and y is from 0 to 1. Find the marginal densities f sub x, f sub y, and the conditional probability f of y given x. Find the probability that the spectrum shifts more than half of the total observation given that the temperature is increased to 0.25 units. So first, let's have f sub x. F sub x is the integral of 10xy squared. If this is a sub x, if this is a function of x, we are going to integrate it with respect to y. And y is from x to 1. So this would be 10 over 3 x y cubed from x to 1. So this would be 10 over 3 x minus 10 over 3 x to the 4th. This is 4. X is in between 0 and 1. For the second one, f sub y, so we have 10xy squared dx, where x is from 0 to y. So 10y squared times x squared over 2 from 0 to y. So the upper limit would just be y squared, so that would be 5y to the 4th. For y is in between 0 and 1. For the third one, for the probability of y given x, it would be 10xy squared over y given x. So y given x, so dividing it by this one, so it would be 10 over 3 x times 1 minus x cubed. I just simplified this. I factored out 10 over 3x. So what's left will be 1 minus x cubed. So we cancel out 10 and x. So what we have is 3y squared over 1 minus x cubed. So this is the marginal densities. For letter B, Find the probability that the spectrum shifts more than half of the total observation given that the temperature is increased to 0.25 units. So we're looking for the probability that y is the proportion of spectrum shift. So more than half, greater than 1/2, given that the temperature x is 0.25. So this would be the integral from 1/2 to 1 of 3y squared over 1 minus 1/4 cubed dy. This can be integrated using your calculator. 1/2 to 1 of 3y squared over 1 minus 1 over 4 cubed. So this is 8 over 9. So let's have this one as an activity for you to solve. So these are some of the references used for this study.